Blog Talk Radio.
Welcome, everyone, to today's Earth Energy Forecast Show on this Tuesday, April 9th, 2019. Thank you so much for joining us today. Today's show is going to be spectacular. I know it. Let me just give you a preview. It's really important to this show that I started. That's why I feel so psyched about today's show. We're in the midst of the shift of ages. For those of us who follow a spiritual path, we have been told that we are in the times of great change. The Hopis speak about a time of great purification when one world ends and another begins. And they talk about the number of worlds we have experienced. And according to the Hopi, I think we're ending the fourth world and will soon begin the fifth. A world where the heart and mind are no longer separate. And it's interesting they use the term world. I think we'll find out why later in today's show. So we're going to talk about the changing of worlds from a scientific perspective today. If you're at all familiar with my work, you know that I blend spirituality with science. My guest today is one of the reasons I started this radio show. I have been following Ben's work for years. Ben Davidson is the creator of the Suspicious Observers YouTube channel, providing daily updates on solar activity, space weather, Earth changes, and more since 2011. He runs Space Weather News with his wife and provides books, an app called the Disaster Prediction app, and conferences called Observing the Frontier. You can contact Ben at ben@observatoryproject.com, and his websites are spaceweathernews.com, suspiciousobservers.org, observatoryproject.com, and quakewatch.net. Ben will be discussing the evidence for a repeating natural disaster by something outside the Earth, the evidence that it will happen again soon, and what that may mean for all of us. Thank you so much for joining us today, Ben.
It's a pleasure to be here. Thank you for that wonderful introduction.
Well, I'm so grateful you're here today, and I'm sure everybody's wondering how you got started with all of this.
It's a long story that I can try to simplify as best I can. And it actually starts in law school, of all places, which is the last academic forum where you actually are taught how to think, interpret, and question things, rather than just regurgitate answers. I pretty quickly found out I didn't want to be a lawyer, but I continued on through law school. And one of the things a lawyer can do is go into due diligence research, so for people making investments. And it turned out that they, between technological investments, mining investments, and a chemical investment, I rediscovered a love of science that I had sort of forgotten a long time ago. And I just decided one day that, hey, I'm going to do what I do for work, which is basically the top-level expert research, and just apply it to things that actually interested me, which were earthquakes, weather, the sun, and things in space. And it turned out that was a pretty good idea. We started tracking everything every day, and it became pretty clear pretty fast that nobody had ever looked at all of these things every single day. Something would happen on the sun, and then something would happen in the weather. Something would happen in the ground as well. And these patterns began repeating, and they led painting bigger pictures, which has at cosmology, the deepest parts of astrophysics at the largest scales in space, all the way down to the smallest scales as well. And that broad perspective also spans time as well. So looking at everything going on now, trying to make projections of the future, and in doing so, bringing in evidence from the past as well. And so it's a lot of big picture making with tiny, tiny little details.
Well, that's incredible that you can do all of this, because I know you have a very good handle on all of the science behind all of this. But you do have a background in meteorology, I think, don't you?
Yes, I do. I wanted to be the weatherman on TV, but I did not succeed, so to say, in mainstream meteorology courses. I was insistent on bringing in other ideas. I kept wanting to interject the newest papers and the newest research and things from the conferences because I was that fascinated with it. Most kids were drinking on Friday night, and I was seeing what the American Geophysical Union had put out the week before. And so that really did not make me a popular person with a lot of the professors. And unfortunately, I didn't understand that you can't just go charging the gates at 18 years old. You have to play the game a little bit. And long story short, I didn't understand that very well. So it was suggested to me I find a new major, even though I was clearly as good at forecasting as a lot of the professors. But I did find a new major and a new university, actually. That was at Penn State, and I ended up going to Denison, which is a smaller university in Ohio. But yeah, it did begin as me wanting to be the weatherman and me taking a lot of meteorology courses.
And so you truly did become the weatherman, the space weatherman.
Right.
It's interesting how our life takes us in certain directions, and we don't know why until later on.
Certainly.
So I find it interesting that the first actual photo of a black hole is set to come out tomorrow.
Right.
That's quite a bit of news, I think.
Right. I'm pretty excited about this, actually.
So we've had an idea that black holes are shaped like a torus or a donut, and I'm just wondering what your thoughts are about this.
Oh, absolutely. The model that we've been working with for a while now, and the model that people like Anthony Peratt from the Los Alamos National Lab have been working with for decades, is based on a torus jet model where basically there is something massive and spherical at the center of galaxies, what they're calling black holes. There's some problems with the specific physics, and so whether it's a gigantic ball of plasma, some kind of supermassive star, really tough to know. But we do know that based on the scaling of the energy, there should be a vertical component north and south, coming out of the axis of rotation, and then around the equator there should be that torus. It should be dusty plasma and gases, and I truly am expecting to see a good bit of that, unless unless the Event Horizon Telescope actually got down deeper than the dusty torus, which I doubt, but they may have done that as well, and so. There's a lot of hype for this. I hope it doesn't disappoint for their sake.
Yeah, really. I'm looking forward to it.
Right.
So let's talk a little bit about where we are in this process. And I know we're in this process, and probably every scientist would agree that we're in the process of a pole reversal. Where are we? And I know you're going to talk about the potential causes for this pole reversal.
So to address the question of where we are with it, the magnetic poles do not hug the actual North and South Pole. They tend to meander around the Arctic and Antarctic, and they, over long periods, move at about 3 kilometers per year. That really started to change about 150 years ago. They began accelerating. It was absolutely flying at about 60 to 70 miles a year across the Arctic Ocean. It is moving faster than the South Magnetic Pole, but the South Magnetic Pole has a huge lead. It is actually already left Antarctica and is moving northward into the southern parts of the Indian Ocean. And as this is happening, we are concurrently noticing a weakening of the magnetic field that surrounds our planet and protects us from all of the dangerous energy from the sun and the galaxy and supernova and gamma rays, things like that. And what we know is that this does happen cyclically on the planet. And the main question mark when this information started to come out was, well, okay, is this just a little acceleration of the normal pole movement? Because they think that can happen sometimes too. Or is this, in fact, a full-scale event? And while there hasn't been a whole lot of mainstream direct express fear-mongering, such as, hey, with this magnetic field reversal, there has been all of the evidence that one would collect to come to that conclusion on their own. The scientists are scaring the monkey out of everybody, but they give you all the information to make that conclusion yourself. And so it does look like even during the intermittent accelerations, it's this fast. And normally during the intermittent variations, you don't get a concurrent weakening of the magnetic field as well. And we do see that it's happening rapidly. About 10% of the magnetic field from 1850 to the last 10, 20 years or so, we've lost.
You're breaking up a little bit, Ben. Can you hear me, Ben?
Yes, I can hear you. Can you hear me?
You're breaking up a little bit. We missed a little bit of the end of that.
Okay. I was simply saying that most of the time during the intermittent period where the magnetic field will move a little bit more, we usually do not expect to see the current weakening of the magnetic field. And so one of the signs that accelerated pole movement is an actual magnetic excursion or magnetic reversal, and not just the pole is doing, is that there will be a concurrent weakening of the magnetic field, because when we do see these reversals in the past, it looks like the field strength that was protecting our planet dropped to maybe only 5 to 10% of what it normally is. So
we lost you again. Are you there, Ben?
Can you hear me? Can you hear me now?
Yeah, I can hear you now, Ben. It's the magnetic. It's the magnetic field that's decreasing, and it's letting too much of the solar radiation.
Yes. Well, as the magnetic field gets worse and worse, these sorts of things will continue to happen. Essentially, yes. The main idea is that this some intermittent acceleration of the pole movement. It has the magnetic field weakening along with it, and so we do know that we are amidst one right now. We are more than 100 years into this event, and we know that 2 of the events in the last few million years occurred in 80 years and about 100 years. So if the reversal were to happen tomorrow, it would not be the fastest reversal that we know about. It would be in 3rd place. Now, what that tells you is that, okay, you could look at it from a positive perspective as, oh, maybe this one won't be so rapid. Or you can look at it from the perspective as, oh, wait a minute, these things can happen much faster than this. Things are accelerating. Are we really in the danger zone now? It's not unthinkable that they happen this fast. They happen faster than this. Could we really be in that danger zone? And that's what a lot of the evidence is suggesting.
Yeah. So let's talk about that danger zone. Because when I was listening, you have a whole series on YouTube on the Earth catastrophe cycle, and I think I've watched every video. And I think in one of them you were saying that you feel this catastrophe, which would include the magnetic poles reversing, would happen in your best guesstimate in 30 years, or could it happen sooner then, from what you're saying?
Absolutely. It really could happen sooner. And it really depends, everybody's guess on when it's going to happen really depends on what they're focused on the most. When it comes to the magnetic field, it looks like any time in the next couple of years to maybe a couple of decades could be the danger zone. When we're talking about some of the triggers for these things, there really isn't necessarily any predictive data that you can use. In some cases, we don't know if there is predictive data or not. And so I guess this would be a good segue into some of those causes, some of the causes of what this might be. And so what's interesting is we have this phenomena with all of the considerable extinctions in the fossil record. Many of them show these very, very brief, fast die-offs of species. Many of them are found in what are known as surge deposits. Essentially, if you can picture what would happen if you basically just took a giant ruler the size of the state of Texas and swept it across the land, what you'd have at the other end of it, everything all mashed together, trees, animals, bones, blood, grass, that's a surge deposit. They can happen from earthquakes, from volcanoes. They can happen from tsunamis as well. A lot of different ways to create one. We also notice that there are phenomenal amounts of snow that are dropped on parts of the planet. These events seem to trigger the ice age climatically, cyclically over time. And the fascinating bit about that is it is occurring over just a couple of days to weeks. And you can tell where the water came from because there's evidence of massive sea level drops. But you come upon this problem. How do you evacuate seawater to get the drop in sea level and then somehow transition from that heat to an ice age? And this is a very complicated problem, and it happens really fast. Now, the way this happens is there has to be an energetic event that is not enduring. It doesn't last. It really comes as a blast and hits us. And then the aftermath, the after effects of it, all turn the planet cold. And so, taking together all of the evidence and somehow leading a way to evaporate massive amounts of ocean, freeze it and dump it as snow, the magnetic reversal of Earth. And then you also have to take into account the other kinds of evidence, the evidence that's not geological, the ones that are archaeological or anthropological, the stories we have, the petroglyphs that are carved in rock. There are stories from around the world, and they all seem to either talk about a battle in the sky or they express the sun or a massive outburst. And you begin to realize that, okay, let's take a look at the sun, because as something that could affect the entire planet like this, the sun is not a bad candidate. And so you begin to ask yourself, what can the sun do to Earth? And so I first started looking at this, and I was thinking solar flares and the kinds of things that you normally see with the sun. And unfortunately, all of those are going to end up with a warmer Earth, and warmer Earth via electrical conductivity, and not going to evaporate the oceans or put that water into the atmosphere, let alone freeze it. Like I said, the world would heat up due to electric current heating. It's known as ohmic heating. But a man named Douglas Vogt had this idea, what if the sun actually knows? Now, my first reaction to this was, you're completely barking mad. because when I think supernova, I think the end of a star. I think the death of a star. But it turns out that there are quite a number of what they call recurrent nova. These things go boom again. They go on as short a cycles as just a few years. There's a galaxy that they believe goes every single Earth year. There are some that they've only seen go twice in the last century, meaning that they have periods in between them of 80, 90 years. And we just got lucky to see one way back then, and then it went boom again, in the last 20 years or so. And the only thing the astronomers are willing to say about the future of that science is that a ton of the nova that we have seen go once will go again, and they will make this list of recurrent nova. And that there are some with hundreds to thousands, maybe tens of thousands of year time scales that we not only haven't seen go boom once, but even if we were to see it go boom tomorrow, we'd have to wait hundreds or thousands of years to know it was a recurrent nova.
Right. Mm-hmm.
Everything on the sun is about cycles. You have a harmonic cycle that goes 11, 22, 44, 88 years. You have another cycle that's 200 years, 400 years, scaling up to 2,000, 2,400, and 3,000 years. And the only place where all of these cycles really sync up and come together in a resynchronizing point is about every 12,000 years. Mm-hmm. Now we're going to step away from the sun for just a moment and take a look at this idea of 12,000 years. Every 12,000 years back in the past, it appears that's when these cycles are happening. Last time it was known as the Younger Dryas event. That was about 11,900 years ago or so. It's really a guess when you're looking that far back in time. Sometime around 23 or 24,000 years ago, 36,000 years ago and 48,000 years ago, all the way back to 7,000 years ago. And before that, and indeed going back in time, the evidence is harder and harder to see as time and the slow crawl of geology and all of the catastrophes that occur afterwards work to cover up the evidence of the previous one, but they still see them. And you realize that, okay, we have these magnetic events about every 12,000 years. Something that was a big part of the series that you mentioned was the account of Major Maynard E. White, the leader of Project Nanook, the first team to go to the Arctic from the U.S. military, and they actually found the magnetic North Pole. The geophysicists at the Pentagon and the CIA confirmed to him that, yes, this is a 12,000-year cycle, and those lines of black coal underneath the ice that you're finding there, line after line, are indeed surge deposits and fossil records. And so you take that knowledge that a rock tells a story. We have a military man basically giving CIA and a Pentagon secret information through his son. And all I can say is if you read the book and you ever listened to a parent or grandparent who served, you know every word he's writing is true. You can just tell it's a person who's listened to these stories for a long time. Right. I guess that's a non-scientific feel kind of thing, but hopefully somebody knows what I mean. I listened to both my grandparents talk about it. The point is that you have the evidence in the rock. You have the evidence in the fossils. You have the evidence from quasi-secret science. And then you look at the sun, and the only place that all of the known cycles sync up is right on that 12,000-year mark. Now, this would not be the kind of nova from the sun that we've seen on a sci-fi program or maybe in a sci-fi movie. This would be what I have to call a micronova, very much a busting off of just the most external dusty plasma shell. And what's interesting about that is the heat of that event. is going to hit Earth. And immediately following the heat of that event hitting Earth, everything freezes. And here's why. Because Earth's atmosphere is full of dust from the nova, and it's full of clouds from the electrification, attracting the dust and attracting the water vapor, creating clouds. The area in between us and the sun remains heavily dusted for days, maybe weeks, blocking the amount of sunlight that can reach our planet. And so essentially, a nova causes immense heating followed by an ice age. And this would be about the only thing that can account for all of the evidence. There have been a ton of phenomenal ideas about how some of these things have happened over time. A lot of people think that there's an impactor that caused the Younger Dryas event 12,000 years ago. Well, it's hard for an impactor to reverse Earth's magnetic field, and it's hard for it to have the scale that it would have had, and actually, that they would have needed 12,000 years ago to create that event and actually left anybody alive. Not to mention the fact that when you're looking at craters, the sun is busting off an outer shell. It could be smaller impactors from the size of your fist to the size of, a house or maybe a city. It is the sun, after all. And what's interesting, even further on top of this, is that it appears that the dozens to hundreds of researchers who have all been trying to seek out these answers before have all been dancing so close to this realization. One of the best examples, and I use this example because everyone knows the name, is Albert Einstein. A lot of people don't know Albert Einstein was 100% a catastrophist. He did write the foreword for Charles Hapgood's Earth crustal displacement. He wrote it before he died, and then the book didn't come out for like 6 or 7 years. So who knows how much of that book Einstein actually agreed with when he wrote the foreword, and how much was changed afterward. Charles Hapgood was a CIA guy after all. But the point was that Einstein saw evidence of not only this catastrophe cycle, but the world turning over, literally tilting 90 degrees. And he spent years trying to figure out the mechanism because he was so convinced by the geological evidence.
Uh-huh.
And
and we lost you again.
Oh, I'm sorry. I'm here. It looks like there's an elegant cosmic 12-inch code.
And you're going in and out again. So you're going interstellar there, Ben. But I think Einstein never really came up with the reason, right? He never, because you're going in and out.
He had the idea that there was something that would unlock the crust from the mantle.
Uh-huh.
And that had to be it, because there was no other way the crust could turn over in it. Because even though it is rock sitting on liquid mantle, it doesn't act like something floating on water. It very much acts like plastic rock. So imagine if you take, a thin piece of saran wrap, and then you put another one flat down right on top of it, and try to take them apart by grabbing the corner of one and sliding it across the other piece of saran wrap. You're not going to overcome that friction. You're going to yank both pieces. They're not coming apart.
Yeah, it's all
what
a
they
function
know
of
is
friction.
that the friction that's created there, just below the crust and just on top of the mantle, in that delicate area in between, known as the low velocity zone, it is based on both a thermal and electric equilibrium. And this is the kind of thing that could be very easily disrupted by a powerful solar burst. Not only when some of the highest energy particles reach the mantle, but the induced currents from the solar blast could reach them, or maybe even reach the core. And so this will significantly disrupt that thermoelectric equilibrium and it would allow the crust to sort of shift freely on top of the liquid mantle. This is also interesting because we are learning from material science. One fun thing about this is you get little keys and clues from all different fields of science to actually work with nanomaterials. Realize that by applying an electric field, that an electric current field could actually flip the polarization. They could reverse the magnetism of the entire thing to which they applied the field. Well, the sun, when it gives out a strong blast like that, it is blasting out an electric field, an electromagnetic cloud of charged particles, and much of it rides along a current sheet. There's this electric sheet through the solar system as well. The planets go across it as they orbit around the sun. And so it really actually does become the one thing that could actually explain all of this. You know, Einstein never once thought about the sun in this regard. Nobody really thought about the sun until, I would say, the 70s or the 80s. And really, even then, there weren't many people who were too focused on it.
Mm-hmm.
But it does look like the ensemble of cosmic coincidences I was mentioning was that as we are approaching this time here where it looks like this thing could be coming soon, all of the evidence and all of the previous researchers' work is now coming together to paint that bigger picture that I was talking about before. And we finally have the tools, not only to understand these cycles on the sun, which really actually lets you do this. We couldn't have figured this out before just a couple decades ago. But to monitor the sun days, weeks, and perhaps even months ahead of time, understanding physically and chemically what the changes would have to look like on some of these satellite images, such that literally having something like a nova watch is real. There are a lot of things that we all know to look for, not to mention that if the sun just starts looking strange in general in all the different wavelengths of light, we have the technology to know that now. And it's almost as though if you think of putting together all of these past researchers and new evidence that is coming out from material science and our new technology that allows us to see these things and understand these patterns and these cycles that let us build that bigger picture, you can very much think of it as a soldier picking up his helmet, his sword, his shield, putting on his chainmail, his boots, getting all the tools needed. But that happens right before battle. He doesn't do that a fortnight out and then just go sleep in bed, every night next to his wife.
Can't sleep and all that.
No, so it's a very elegant thing. It almost does seem like we're going to need these tools. We're going to need this information soon. And there's a spiritual side to this too. And
definitely,
I don't think it's at all coincidence that these things are coming together exactly at battle time, if I may put it in those.
In that term, yeah, it's interesting. I have Celia Fenn coming on next week, to talk about the ascension process and what all this light is bringing us and the changes in our DNA, because all of this is affecting us. We're electromagnetic beings, and of course we're being affected by this because the Earth shields are low, and all of this is coming in. I know that in your series you have Dr. Paul LaViolette on, and he talks about the galactic supernova starting the whole process as the trigger, as maybe coming from the great central, the great central sun. I mean, it could be like that far back. The whole universe, as I call it, I see it as a container. I say it's a capital U, containing all the multiverses. sending out this, okay, here's the next, cycle. We've got to clean the slate and start over again. And it comes from without the sun, farther away. Is that something that is plausible?
Absolutely. I have been looking most favorably at a galactic trigger. It would not be the same as the galactic core shockwave, simply because there would be such a disparity between when the light, when the gamma rays and the X-ray photons arrive and the particles, possibly, it would take the light 50,000 years to get here, and then, maybe a million years for the particles. All of these cycles would sort of be running together at this point. Not to mention the fact that we don't see that sort of thing at any galaxy, at any amount of light years away in the cosmos. However, what we do know is that everything is scalable. And what we do know is that while Earth, all right, so let me step back for a second. Earth's orbit around the sun, it's not perfect on the solar equator. We go 7 degrees north and 7 degrees south in our orbit. Now that means that as we're going from north to south, and then as we're going from south to north, twice a year, we will cross that equator of the sun. However, do you remember that thin current sheet, the electric field rippling through the solar system that I mentioned? Well, it really does ripple through the solar system, and because it ripples up and down, it doesn't hug the equator either. And it rotates with the sun about every 27 days, which means that every 27 or 28 days, this thing has rotated such that both a north and a south have passed by the Earth in terms of the electric current environment. So we go around the sun in 1 year. Twice a year, we cross the solar equator, moving slightly up or down from a solar latitude perspective. But about every 2 weeks, we cross a solar system current sheet. And even if there's no solar flares, no increased solar wind, just the reversal of the interplanetary magnetic fields of the solar system can cause a geomagnetic disruption on Earth. Now, this is important at the galactic scale, and this is where your mention of the black hole comes in. Just as a black hole or a plasma nucleus should have that dusty, energetic torus around it, the sun has one too. So does the Earth, the Van Allen belts. We know that there is an equatorial ion fountain that comes out of the equator of Earth. It's mostly oxygen ions, and they don't make it out very far. But Earth blasts out that field of electrically charged ions from the equator, just like the sun does at a smaller scale. So let's take that up to the galaxy and ask ourselves, okay, if the sun goes around the galaxy every 250 million years, how often does it actually hit the galactic current sheet? Because that would be far more often. It takes us a year to go around the sun. Every 14 days, we're going to get whacked with the solar current sheet. And what's going to happen? Does the sun take an electromagnetic disruption to it, just as the Earth does when it crosses through the sun's current sheet? Would this be something that would happen quietly at every star system as it happened to them and could hide in plain sight in the galaxies and the cosmos? It's kind of hard for a galactic core superwave to hide in the cosmos. We'd probably see something like that, but just a simple crossing of a magnetic zone. The folks who back in 2011, 2012, who were really worried about a pole shift, they were saying things like Earth is going to cross the galactic equator and it's going to be a reversal of the galactic magnetic fields. I don't think those people were as far off as they realized. Now, granted, we have been in the northern hemisphere of the galaxy for 7 million years, and I think we've got 17 million years left in the northern hemisphere of the galaxy. But at rippling current sheet, doesn't care where the galactic equator is. It ripples up, it ripples down, it ripples north, it ripples south. Just like the sun doesn't care about the solar equator. It ripples north, it ripples south, very predictably and with electromagnetic disruptions coming to it. So all of a sudden, the sun begins to enter this magnetic null zone, this magnetic reversal area of the galaxy, and it hits that electric field. And, is there extra dust there to begin with? That could certainly interfere with the coronal and solar flare and the different chemistry on the surface. The electric field itself, is that going to reverse the polarity of the sun out of phase and unpredictably? It's hitting that electric field, and the extra energy going to cause it to light up like a comet who spent 10,000 years in the Kuiper Belt and is tasting solar wind for the first time and outgassing like crazy. We don't know the exact path it takes from there, but we do know that by all means the solar system should get hit by this galactic current sheet. It's not some explosive, bright event that scientists would have seen at this point. It is a quiet region of magnetic reversal and electric field in between them. And we know when it happens to Earth, it can almost produce geomagnetic storm level activity. Now, normally on the sun, even the difference between no sunspots and the highest sunspot number we've ever seen isn't the difference that we see on the planets. And so we've never really seen any kind of electromagnetic disruption to the sun globally as a whole. Not sure I want to see what that looks like. But that is probably, that is probably the answer. And the folks who have come to study this for the majority of their lives, they usually end up blaming the galaxy triggering the sun.
Mm-hmm. Well, from a spiritual perspective, everything is connected. If you go along with the Hermetic axioms, as above, so below, as within, so without, and it's like, once you affect one thing, it affects another. It's like playing billiards up in space, if you throw this energy at that, there's got to be a cause and effect. So it makes sense. Dr. LaViolette talks about a bluish-white star that the core of the sun has exploded. Is that what we would see if the sun goes to micronova?
It's really tough to tell. I have never been able to reconcile the various stories of blue objects, red objects, yellow objects, white objects. Sometimes, just as soon as I think that they're talking about the sun with one of them, I read 3 or 4 things that make me think they're talking about a comet, or I read 3 or 4 things that make me think they're talking about magnetic reversal on Mars or on Venus, where that planet lights up energetically, or on Jupiter. I don't know what a magnetic reversal event on Jupiter would look like, but its atmosphere might get so electrically charged that it might just start emitting light like another star. We don't know. It's not far off right now, I can tell you that. All you have to do is think about Earth. Many people know that we have an ionic layer above our heads. It's a globe, but the actual electrons are thousands of degrees. How much more energy is needed before that would start to actually glow and Earth would look like a star? These are very legitimate questions you have to start asking when you're talking about losing 90 to 95% of the magnetic protection of the planet.
Yes. I was just wondering because there is a Hopi prophecy called the Blue Star Kachina.
Right.
I don't know if you're familiar about it, but but when I read this, I'm like, wow, that could be what they were talking about. They were talking about it would be the final sign before the days of the Great Purification, that you would see this blue star in the sky and then it would become crashing down. So that's like, wow, could that really be it? And the depictions on the petroglyphs, are just stunning when you look at what scientists, guess what it would look like for the sun to go through these changes and what they depicted.
Right. Oh, absolutely. But think that a lot of the changes would be relatively obvious. It is hard for me to hear so many stories of things like either the sun rising in the wrong place, setting in the wrong place, the long night where they thought everyone was going to freeze to death before the sun finally decided to come up, the stories of the sun being red and stealing civility from the people. Even the Bible is not the only story that talks about a black sun. If you change the energetic state to where it's emitting mostly in ultraviolet and not in the visible range, it's going to look black. If you blow off the outer shell, and you basically just you see right down to the surface of the sun, and you don't have all this gas and plasma and other things up in the corona, aka the atmosphere of the sun. Those are the things that are emitting visible light. If you don't have those, the sun just looks black. It's still hot. It's still providing the ultraviolet light, but it's actually causing a bit of air glow. So it would be fairly bright in the daytime as well, and perhaps even at night because of the extra ionization. That might not go away as soon as the sun set. Actually, could be sort of a perpetual glow through the evening and night times. But it would just look horrifying.
Yeah. So
and,
what?
As I said, it's not just the Bible that talks about that either.
Yeah. So what might we expect, to happen when this occurs? I mean, obviously, even a large solar flare like what happened in the Carrington event would just fry the grid. What are we talking about here?
Well, I think that losing electricity is probably a given. If the sun decides to rock and roll, whether it's a powerful solar flare or this micronova that I'm describing, there's a very good chance that us or our children or grandchildren are going to have to live in a world without electricity, rebuilding everything from the ground up. When you think about wires catching fire in the Carrington event and realize that everything is more interconnected and more vulnerable now, imagine every copper wire in the world melting. Imagine you can't, even if you could fix it all and create a time frame, who's going to do it? Who's got the vehicles? Who's got the machinery? Who's got the manufacturing? How do you get it there? There's no gas stations.
Right. There's no manufacturing. There's no vehicles.
Where do you take them? There's no phones to call in an order. It's that kind of thing, but more than that, because that we know that humans can do. I mean, there are places in the world where people live without electricity just fine today. What's a problem is the inundation of the sea. What's a problem is the cold. What's a problem is the initial cosmic ray bombardment.
Right, the radiation. Yeah,
the wind, the weather, earthquakes as everything in the crust begins to settle back down, crash into each other, lift, fall. Some lands will rise out of the sea. Other lands will fall, like Atlantis, Mu, and Lemuria. Those were once great places that sank into the sea. And so there is no doubt that in the initial event, a lot of who survives and who doesn't is luck. There's no question about it. But then, of course, there's always the fact that you have to remember that those petroglyphs describing this, which, by the way, are only one form left behind of descriptions. People carved it into other things and deep into caves. They told it in stories, but just the petroglyphs themselves, found on rocks at wildly varying latitudes, tells you that people do survive at least the initial burst almost everywhere. There are going to be pockets of people who survive this all over the place. And unfortunately, given today's society, the vast, vast majority of those lucky people are going to be petrified. a few of those lucky people will be prepared. And that's what I've been trying to get across with this series, that,
right.
if it is your time, and there's a super volcano that goes off next to your house, as your land sinks into the sea, you have no chance. But wouldn't it be a shame to watch what I'm going to playfully call God's theater run out before your eyes, to survive that event and then die because you can't find water or you can't find food or you freeze to death? That's like the most absurd shame I could ever imagine. Being so lucky as to witness that, being so lucky as to survive it, and then failing to do your part to bring people back because you didn't know what you were doing, or because you spent too much time watching Kim Kardashian's Instagram feed or something like that.
Right, yeah. And it goes back to what the Hopi said with Prophecy Rock. If the white man followed that line, we would die. But if you followed the Hopi path, it continued all the way around the rock. It continued. And that life of living off the land, of being connected to the earth, of being connected to the sky, and knowing how to live without all these comforts that we have now, all the electrical things that we have, that's how they would survive.
Right. Well, unfortunately, we have a bunch of people in today's world who are trying to survive another way, the hard way. Digging bunkers, buying old missile silos, and getting their bomb shelters ready and things like that. I can't really say that, those are going to necessarily hurt someone in a given situation. But we are seeing that because of the way the population is now, they're going to many of them will try to rely on something completely different. So, have you heard of the mountain that Jeff Bezos is hollowing out in West Texas, down there at the border with New Mexico?
No.
So, it's in the Sierra Diablo Mountains, really, New Mexico and West Texas. And on one side of the state line is the Blue Origin West Texas launch facility, where Jeff Bezos' Blue Origin, space flight company, has their launch pad. And right next to it, on the other side of the road, he's hollowing out the mountain. Now, it got public that he was doing that, and he very quickly, and through the use of a lot of money, came up with a great publicity cover story. He's building a giant. He's building a giant forever clock inside the mountain so that future generations can come look at it. So, because Bezos is doing this because, one, he has the money, and two, he doesn't know if he wants to go up or go down. For all he knows, he might want to send his kids to go hide behind the moon. We don't know. He might want to go underground, which we know a lot of people survived underground in the past. Underground tunnels on nearly every continent. So it's interesting, and there doesn't appear to be, as much as communities like ours like to think it's us versus this well-organized, well-planned group of elites ruling the world. I have to just say that while there's a part of that is true, they're also just as dumb and scared and disorganized and silly as you could possibly imagine. So Bezos is doing this himself. He's not part of some big grand scheme. This is his plan. There are a lot of people who are just really sort of taking we're on our own type thing. There are corporations who have taken it upon themselves to have safety places for their board and their officers and things like that. It doesn't get very well publicized, unless, of course, you know what you're looking for when you see that Jeff Bezos is building a forever clock inside of a mountain and you go look at it, and you're like, wait a minute, is that his launch facility right across the road?
Yeah.
It's not obvious. They don't come out and say Jeff Bezos is building a survival plan here. They don't come out and say things like that. I don't even think the journalists would probably be able to put things like that together. They don't have the broader perspective or know what's going on. Think about all the things you'd have to know about to come to that conclusion. I mean, you'd have to be somebody who considered themselves a truther or awake or into alternative ideas or alternative news. You also would have to understand the Earth catastrophe cycle and a lot of the science involved with it. It's a very difficult, large picture to put together. I'm very, very lucky that it was my job before this, or else I'd never be able to pull it off.
Yeah, and I'm so glad that you're doing it too, Ben. Because we all need this information, and that's one of the reasons I started this show, and to get out other information of what we can do to prepare, to mitigate it, or whatever we can do. And so people are aware of it, because so many people aren't. And I don't think that it's going to be shared that much mainstream. So it's important stuff. Is there anything else you want to share with us today before we end our show?
Just that everybody listening to this is down the line of a survivor, a champion of humanity that watched one of these things happen and survived. Otherwise, you wouldn't be here. This has happened time and time again, and we are all here to tell the story now and try to figure out what's going to happen and when it's going to happen. And every chance is a chance to do the world the right way, to fix mistakes. And it's going to be the people who survive and are able to teach their children the right way to make the world that is going to determine how the next age begins. And that's important for everyone to remember, because we have no idea who's going to get lucky and who isn't.
Yes. And, I'm encouraged by what the Hopis say about the next world coming. It's coming. So, yes, and we'll see what, as you said, there's a spiritual component to this as well. And what might be changing spiritually for us and how we could further step into our power. There's those that say that they were, had a past life in Atlantis and, we blew ourselves up or whatever and we didn't make it and now we're going to do it this time, whatever. I am of the opinion, what could it hurt if we do ceremony at sacred sites? I had a person on talking about that, and that was one of the reasons why the sacred sites were built. So whatever we can do, I think is a good thing, and in addition to preparing, eyes wide open, like
Absolutely.
you say. Thank you so much for yes. Thank you so much for coming on the show today, Ben. I really appreciate it. And there's one way I'd like to end my show today, that the way you end every one of your videos, because I do love what you say. Can we say it together?
Absolutely. Why not? You want to start?
Okay. Eyes open. No fear.
No fear. Be safe,
everyone. Thank you, Ben. Take care, everybody.
Very much
love.
Have a great day.
Thank you, Ben. Take care, everyone.